So hello everyone. Now we are going to solve a CF problem. The problem name is modified GCD. So let's start uh, via reading the problem statement and then we'll be proceeding further. So let's read it. Here is another math class task in mathematics. GCD is greatest common divisor. We already know it's an easy task to calculate the GCD between two positive integers. All right. A common divisor of two positive numbers is a number which both numbers are divisible by. We already know it. But your teacher wants to give you a harder task. In task, you have to find the greatest common divisor B between two integers A and B that is in a given range, low to high. It is possible that there is no common divisor in given range. Okay. You will be given two integers A and B, then n queries, and for this query you are given a range, and for that particular range you need to find the answer. Right. So mm, you have to find the greatest common divisor of A and B, but the thing is you need to find that in the given range between low to high. And yes, that's all the overall problem is all about. So pretty simple to understand. Like if we open this and dry run the case, let it open. Uh, oh, it is taking some time. Yeah, open. So let's erase it first. Yes. And now let's start our part. So here let's place our data. So these are A and B. This is N and these are the query points in which one is low and other is high. Okay. So if we look at 9 and 27, so and for these numbers, the GCD in range 1 to 5, what it would be? Definitely 3. Why? Because 5 doesn't divide these two, 4 doesn't divide these two. And if we check for 3, yes, 3 divides 9 and 3 divides 27 as well. So 3 is the answer for this case. And if we look at here for 10 and 11, so 11 doesn't divide this 9 and 27, and 10 also doesn't divide this. So for this answer would be -1. And if we look here, 9 and 11, so 11 doesn't divide these two, 10 doesn't divide. But if we check for 9, 9 divide 9, yes, 9 divide 27 as well. So the answer would be for this is 9. Right. So basically, we have till now we have understood that what we need to do in this problem. So means what the problem is all about. So, but there is a catch, and catch is there in the constraint. So we are given the time limit as 2 seconds. So we know that 1 second in 1 second our computer perform 10 to the power 8 operations, and for 2 seconds, sorry, in the 2 seconds our computer is performing 10 to the power 8 operations because in the problem we are given. So in 1 second, basically, sorry, in 1 second, it would be performing somewhere around 1 by 2 into 10 to the power 8, with, which is 5 into 10 to the power 7 operations, right? So if we try to brute force it, like iterate from the range and select the greatest divisor, as simple as that. So for that, I think let's code that approach up, and then it would be easy for us to detect that what is wrong in that particular solution. So let's code that solution up. So let's remove it as of now. This was the optimal solution that I was going to code. But let's code the brute force one, like what directly comes to your mind. So int n, if we have taken the inputs, and for as n will decrease, we are given int low I, right? And if we iterate I is equal to low till I plus plus, and if a divided by I is equal to 0 and b divided by I is equal to 0. So let's write it as CNT, means the largest integer possible. Initialize it from 1 because when the divisor won't be present, we need to print -1. So we'll update CNT as I, keep updating it, and it will get automatically gets updated to the largest possible value. And if we print, all right, so definitely it would be passing the sample inputs, obviously. Yes, and if we try to submit it, then definitely it will give us the theory. I'll explain why. So if we try to submit this up, hmm, it will run, and eventually it will give the TLE on test number 5. So why it has given us the TLE? So for the thing that we have calculated so far, we need to solve this problem in less than this number of operations. But in this, if we look at the constraints here, uh, the modified GCD problem, If we look at the constraints, the value of a and b are 10 to the power 9. So let's write it here, 10 to the power 9. And the value of low and high are uh, also 10 to the power 9. And the value of n is 10 to the power 4. So if we look here, mm, I should move a bit. Yes. If we look here, that for the iteration we are doing it here, it is in n, obviously. So we go of n, right? And inside n, we are iterating from low to high. So definitely it will be a complexity of uh, high minus. I am denoting high from h, high minus low from L plus 1. Fine. So if we substitute the values, like the numerical values, the value of n is 10 to the power 4 into the value of high is 10 to the power 9 and low is also 10 to the power 9. So somewhere uh, it would be 10 to the power 9, right? So that means it is 10 to the power 13. Fine. And what was the required TC for the problem below which the code would be acceptable is 10 to the power 7. So means definitely there is a vast difference between these two. So this will give us TLE, right? Understood? Fine. Now, so we need to think something else by keeping this idea in mind, in our mind. We need to do actually this, but in a different manner. So first, what we are doing here, we are checking each possible divisor between low to high. So can we think of something else? You would definitely be knowing that when we calculate the divisor, we iterate in the for loop from 1 to n, and sorry for the handwriting, but try to understand the idea. So we iterate in this loop and we calculate the divisors in pairwise format. So it reduces the time complexities significantly and takes it to big O of root n. right? You'll definitely be knowing this. It's a pretty simple idea. When we try to study array in starting, we get to know that there is this method to calculate the divisors. So it reduces the time complexity significantly, right? So instead of cal uh, checking for each possible divisor, we can do this, right? Sorted. So that's what we can think of as of now. And one more thing, if we look at the GCD, let's suppose the number are 9 and 27, and if we look at the GCD, that would be, I guess, what would be the GCD? Probably 9. GCD of 9 and 27 is 9. Mm, GCD of 9 and 27 is that. Yes, obviously. 9, 9, 9. So for that would be uh getting the values in the pairwise format. So we'll iterate from I to 9, 1 to 9, and then for each value, what we try to do is that when I would be divisible by uh, GCD, like when I would be, sorry, we'd iterate till root of 3, that is 3, till 3, sorry. So I think we should write the code first, then we'll be able to understand. I think there is some mistake that I'm doing here while calculating. So yeah, basically, I want to say that we would be using this instead of iterating for each possible number. So let's do it now. And mm, let me try run one case so that I would be able to explain it again. 1 minute. So yeah, I was doing it right. So basically, for 1 and 3, uh, 1 minute. Why obvious is on. Minimize this. Minimize this. So yes, uh, for 1 to 3, we'll calculate this pairwise. So 1, 3 would be ones, and then in 2 and 3 won't be possible. So then it would be sorry 1, 9, 1, 9, because G is 9 na. So 1, 9. Sorry for the handwriting. I know I'm writing pretty bad, like very very bad, not pretty bad. So 1, 9, and the second one would be 3, 9 divided by 3, 3. So we'll reject 3 because we can't repeat the value. So the number of divisors would be 139, and it gets calculated in Vigo of root of 9, that is 3. Means it reduces the time complexity like significantly, and the larger value is 9. So sorry, the larger value is uh like let's do it till here, and then after we'll be checking for the range. Like we have calculated the all the divisors that were possible, and here if we look at the range 1 to 5, the value that is getting in 1 to 5, the largest value is 3. So 3 is here, and we can see that 3 is our answer. Right. So what the idea that we can derive it from here, that if G is the GCD of the numbers, then all the possible divisors that we require could be calculated via iterating from the iterating root of G. Right. We can we have proved it here. So this is the one thing, and then after that all the things are sorted, and then we sort the divisors, because for the case that we have solved, it was already sorted, but it won't be happening all the time. So let's sort it out, like sort in increasing order, and then after sorting, sorry, I don't have the pen type, that's why I'm writing very bad. I'll be purchasing it very soon. So we'll sort it, and then after we'll return the highest value, let's suppose L, that would be lying in this range. So 1 minute, my Didi is calling again and again, so I'll be taking a break of 1 minute. So where I was, uh, here. So yeah, we need to print the highest value of possible between this range, right? So this is our this part. Uh, this part is our overall idea for solving this problem. Look at the mess that I have created. So this is the overall idea that we require to solve this problem. Hope so I have explained well. Yeah, I know my writing is pretty bad. Like I'm not able to write properly the mathematical part, but I tried my best to write all the things that I could. So yes, this is the solution. Now let's move to the code editor and let's code it up. So that was the our idea that was failing. So I think now it would be visible. So yes, yes. Remove something, remove something. Hmm. Let's calculate the GCD as GCD A, comma B, and here instead of writing this, uh, let's iterate from int I is equal to 1 till I into I less than equal to G I plus plus, and here we can create a vector int divisors, which would be storing the value, and divisor dot if uh, what G dot divide by I is equal to 0, then we will be pushing divisor dot push back I, fine, and if if mm, I is not equal to G dot I. Then we need to write it here. If I is not equal to G mod I, then we'll put this to right. And yeah, this thing is done. And let's sort the divisor. Uh, div dot begin. Div dot end. So divisor is sorted. And now, uh, this thing is done. Like this thing is done, and we need to do only this. And for this, the idea I would be using upper bound because upper bound returns the value that is higher than something. So by upper bound, I would be returning the value that would be greater than high. Oh yeah, my handwriting. Now it's making me frustrated. Uh, let's change the color. Mm, which has been good. I think this one. Let's increase the thickness too, I guess. So I would be returning via uh, what? Via upper bound, the value that would be just greater than high, and then we'll be moving one step back, I minus minus we could say, and then we'll check that if the value is greater than low or not. If it is yes, if it is yes, then that value is probably our answer, means yes, and if it is no, then we'll be returning minus. So this is the best idea I could have think of. So we'll be doing this, right? So let's move to the code editor now. So R2 R2 IT is equal to upper bound div dot begin div dot end. The value would be high, and mm, we'll do IT minus minus means one step back, right? And if the value of IT is greater than low, then possible possibly fine. We'll print the value of IT and real, uh, and if it is not, we'll be printing our answer as of minus 1. And one more edge case that we should handle is that let's suppose if this thing is returning us to the first index of the array, means the value that is greater than high is the first value of the entire array. So what it means that there is no possible element which lie in this range. So means we need to return then as -1. Fine. So if it to div dot begin, that means nothing is available. So we'll write this side our answer and then we'll return. I think the code is done. I have taken the inputs value. Revision is perfect. I have pushed the values. I think here I need to push. I think here I need to push the data. Yes, probably. No, am I writing the divisor code wrong? 1 minute, 1 minute. Let me dry run it once. So let's suppose 1 comma 3. 1 comma 3 means hmm, if 9 is divided by I 1, that means uh, like 1 is dividing the 3. If J is 9 is divided by the 1. 3, 3, 3, 3, 3. 1 minute, 1 minute, 1 minute. Sorry, I was writing this wrong. Like here, I have written module 3 of 5, and then we need to push GY, right? Because we are inserting in pairwise. I think this is what I have written now. It should pass. Yes, definitely passing. And now control C, control. Now we need to do control C, control V, and let's minimize it. And yeah, problem number C, modified GCD. I hope that the problem name is correct. First modified GCD is there, and I think I have submitted the right solution. Now it should pass. Let's wait for a while. And to long as well, not let's press 11. What I have missed. Should it be wrong? Why is it so? Test case 11 clause. Where it is wrong. Answer is -1. I have done something wrong in the code. Am I? We have calculated the upper bound. Moved one step back. If it is equal to return, then return is continue. It is fine. I think I also don't need to take the largest values like in long because the constraints are 10. Oh, sorry, n is 10 to the 10 to the power 4 it is. And probably when I know that for the long is 10 to the power 18. Hmm. I guess so. I think my approach is pretty fine. Uh, Let me check the code again, then I'll submit. Sorry again for the mistake I did. Basically, I'm doing Blender again and again. I was going one step back before checking this condition. And after going one step back, I am checking this condition. So why it won't give me the wrong answer of this related group? That's what the sheer nonsense from my side. No, it will pass. It should pass. Might might be there are another problems in my code because oh wait, let's check it. It will pass or not. Understood na that I should first check, yeah, then I should take care that will it be worth it to go one step back or not, and if there are any uh, possible element that would be our answer, which lie below high. So that's the mistake I did. Basically, what happened now that I tried to implement the code while recording the video, so that I it will create a pressure on me and kind of I need to code all it by myself. So it helps me to strengthen my implementation skills, which I already always lacked. So yeah, that's all for this video. Code is accepted. I hope you have seen it. Yes, here. Yes, it accepted. And I tried to explain everything like best from my side. And oh, if there is any error, so let me know in the comments. I don't know who is watching or not, but if there is, then please let me know. I tried to do everything that came in my mind while uh, right before writing the code, basically, like the theory part and how I could get to like how I have derived solution. So yeah, that was all about the problem and the solution. Hope you liked it. So that's all for this video now. Thanks for watching it. If you are, bye.